Chapter 12.6, surface area and volume of spheres. All right, so the shape of a sphere, it's basically like a ball. Okay, you can think of a basketball or soccer ball. Anyhow, the sphere has a center, just like a circle does, and it also has a radius that goes from the center to the sphere itself. Okay, so it's very similar to the circle. All right, it also has a cord that connects two ends of the sphere. And if the cord goes right through the center from one end of the sphere to the other, that is, of course, a diameter. Okay, and just like a circle, the diameter is 2 times the radius. All right, so the formula for the surface area of a sphere, that is just S equals 4 pi r squared. So S stands for the surface area, and of course, R is the radius. All right, so surface area, 4 pi r squared for the sphere. So just for your information, just so you can see how we got the formula, you can imagine the leather wrapping around a baseball. Okay, this is the leather covering unwrapped. And it basically forms 4 circles. Okay, if you recall, the area for just one circle is going to be pi r squared. Okay, and if we have 1, 2, 3, 4 circles to wrap around the baseball, the surface area for the sphere is going to be 4 times pi r squared. So that's where the formula comes from. Okay, example 1, they want us to find the surface area of the sphere. Let's take a look at the diagram. All right, so here's the sphere. And this is, of course, the center of the sphere. And if you go from the center to the sphere itself, that is a radius. That's a radius, R. So R, in this example, is 8 inches for the sphere. Pretty simple. We said surface area is 4 pi r squared. And that's going to equal 4 times pi times r squared, which is going to be 8 squared. Okay, and just use the pi key on your calculator. 4 times pi times 8 squared. If you don't have a pi key, use 3.14. All right, and rounding off, I get 804.25. The units on the radius were in inches, but the radius was squared, so the inches would also get squared. All right, and if you wanted it in terms of pi, you would just do 4 times 8 squared and leave pi alone. All right, example 2, the surface area of a sphere is 20.25 pi square centimeters. And they want us to find the diameter of the sphere. Okay, let's look at the diagram. We don't really need it. Basically, we're going to work backwards. We're going to set the area equal to 20.25 pi and work backwards to find the radius and then the diameter. All right, here's the diagram, and it gives us the same as in the write-up. The surface area is 20.25 pi. We know that the surface area for a sphere is 4 pi r squared. Okay, and you could do the algebra first if you like. All right, I'll just do it the basic way for now. But really, if you wanted to solve for r squared, you could divide both sides by 4 pi. Anyhow, I'll just take what they gave us and plug that in place of S. So that's 20.25 pi. And that's going to equal 4 pi r squared. All right, now these terms are all multiplied by each other. We want to isolate r, so let's isolate r squared first. Since this is times, r squared is times 4 pi. The opposite of times 4 pi is divided by 4 pi. All right, you want to do that to both sides of the equal sign. Over here, 4 divided by 4 cancels. Pi divided by pi cancels. Bring down the equal sign, and you're left with r squared. On this side, same thing. Pi over pi cancels. I'll do 20.25 divided by 4. I get 5.0625. That's r squared. The way to undo the opposite of something squared is to take the square root. So if you want to undo the squared, you just take the square root of both sides. Okay, square root of 5.0625, I get 2.25. And the square root of r squared is r. They asked us for the diameter, not just the radius. So we said at the beginning the diameter is 2 times the radius. So that's going to be 2 times 2.25, which is 4.5. The units were in centimeters squared, but when we took the square root, it is just centimeters. And that is the final answer. Now, you could have taken the square root right here. You could have just done the square root of this right here instead of doing it in 2 steps. And like I said, you can also do the algebra at the beginning before plugging in for s. You could divide both sides by 4 pi right at the beginning and then plug in. So either way would work. All right, 4.5, answer B. All right, please pause and try number 1. They say the diameter is 40 feet, and they want us to find the surface area. Don't forget the radius is going to be half of the diameter. All right, so you'll have to do that first and then plug in. Pretty simple, and round off to 2 decimals. All right, the diameter is 40. So the diameter D is 40. The radius is going to be half of 40. And of course, that's just 20. So we're going to use R equals 20 in the surface area formula. Okay, we have 4 times pi times 20 squared. The 20 goes in place of R. Rounding off, I get 5,026.55. The units were in feet, so for an area, that is going to be in feet squared. Final answer. If you wanted it in terms of pi, just do 4 times 20 squared and leave pi alone. Make sure you include the pi at the end. All right, please pause and try number 2. They give you the surface area at 30 pi square meters, and they want you to find the radius. So here's the formula. You'll have to plug in and work backwards to find the radius. All right, surface area is 30 pi, so that goes in place of S. And that's going to equal 4 pi times R squared, which we do not have. All right, just like we said before, these terms are all multiplied by each other. We want to isolate R squared. The opposite of times 4 pi is divided by 4 pi. All right, do that to both sides. 4 pi over 4 pi cancels. Pi over pi cancels. And 30 divided by 4 is going to be 7.5. All right, The opposite of squaring something is to take the square root. So we'll just do the square root of both sides. Square root of r squared is just r. Square root of 7.5 is going to be, rounding off, 2.74. The units were in square meters, but when you took the square root, you removed the square, so it's just meters. So that would be 2.74 meters for the radius. All right, so real quick, the definition of a hemisphere is just half of a sphere. So basically, if you took a plane like this flat sheet in pink and it went through the center of the sphere, it basically cuts the sphere in half. So this hemisphere, there'd be one on the top and one on the bottom, this whole thing right here. All right, now we're going to move on to volume of a sphere. All right, and it says the volume V of a sphere is 4/3 pi r cubed. All right, so this right here is the formula. 4/3 times pi times r to the third, where r is the radius of the sphere. All right, so now we're dealing with actual volume, which is 3 dimensions. That's why it's cubed. All right, example 4, a soccer ball has a diameter of 9 inches. They want us to find its volume. All right, as we said at the beginning, a ball is basically a sphere, and we said the formula for volume for a sphere is going to be 4/3 pi r cubed. Now, we didn't get the radius, we got the diameter. So we know that the radius is going to be half the diameter. And that's just going to be half of 9, which is 4.5. All right, you could leave it as 9 halves, but the radius is going to get cubed, so you might as well keep it as a decimal. Okay, so that's going to be 4/3 times pi times r cubed. So that's 4.5 cubed. On the calculator, I'm going to do 4 divided by 3. Hit equals, and then times pi times 4.5 to the third. And I get 381.7. The units were in inches, but that was raised to the third power. So that's actually going to be inches cubed. And that makes sense because volume is 3-dimensional. So rounding off, I get 381.7. Alternatively, if you wanted to do divided by 3 last, you could do 4 times pi times 4.5 to the third, hit equals, and then divide by 3 at the end, same thing. All right, example 5, they want us to find the volume of the composite solid. Let's look at the diagram. All right, this might be a little hard to see here in the diagram, but we have a cylinder. And this portion right here, and this portion right here, that's actually empty space, okay? So we're going to have to find the volume of the cylinder and subtract this empty space, and we can see this is not a full sphere. This is basically half a sphere or a hemisphere. So it's going to be minus the hemisphere. Okay, you have to imagine this is empty space. I don't know if I could draw it here, but if you took away this space right here, that's basically what you have left. Okay, they basically put a hemisphere inside, or remove the hemisphere from that cylinder. Okay, so this hemisphere is empty space. Now, this distance from the center to the circle itself, if you can see the base of the cylinder, that's going to be the radius r. Okay, so that 2 inches is going to be the radius r. And this 2 inches right here is going to be the height of the cylinder. That's h. And if you imagine the cylinder, the same circle on top, this distance for the radius is also going to be the same as the one on the bottom. That's going to be 2 inches. All right. So that's also the radius of the hemisphere. So what we're going to do is the volume of a cylinder minus the volume of a hemisphere. All right. We know that the volume of a cylinder is pi r squared times h. All right. Remember, for a prism or cylinder, the volume is basically base times height. But the base of a cylinder is a circle. So that B would just be pi r squared times the height h. So that's easy. That's for the cylinder. A hemisphere, we said a hemisphere is half of a sphere. All right, we said that already. The cylinder, the hemisphere is half of a sphere. So for a sphere, we know the volume is 4/3 pi r cubed. However, the hemisphere is only half of a sphere, so the hemisphere is going to be times half. So this is, right here, this is the volume of a sphere, but it's times half because it's a hemisphere. All right, now we're in business. We can plug in. This is just pi. R squared is going to be 2 squared. And the height h is also times 2. 1/2 times 4/3. Let's get that out of the way. We're multiplying fractions. 4 divided by 2 is just 2. And we're left with 1 times 2/3. So we have 2/3 here. And that's times pi. And r squared, nope, it's r cubed. That's the one mistake I made there. The volume for a sphere or hemisphere, that r has to be cubed. All right, so r once again is 2 inches, so that's going to be times 2 cubed. All right, you can do this in 2 steps or 1 if you like. All right, just make sure you can do it on the calculator. All right, I would put parentheses around the 2/3 if you don't know how to do fractions on the calculator. But I'm going to do pi times 2 squared times 2. Hit equals, and then minus, and I'll use parentheses, 2 divided by 3, close parentheses, times pi times 2 to the 3rd. And hit equals again. I get 8.38, rounding off. All right, that's 8.38. The units were in inches, but the inches got cubed. For the volume, it's always going to be cubed. So 8.38 inches cubed is what I get for the volume. All right, please pause and try this one. They say the radius of the sphere is 5 yards, and they want you to find the volume and round to 2 decimal places. All right, so just remember we said the volume is going to be 4/3 pi r cubed. All right, pretty simple. This one's just plugging in. So we're going to have 4/3 times pi times the radius cubed. The radius is 5. And that gets cubed. All right, so do that on the calculator and round to 2 decimals. If you don't know how to do fractions, just do 4 divided by 3, hit equals, times pi times 5 to the 3rd. Hit equals again. All right, I get 523.60. The units were in yards, and that got cubed. So it's going to be yards cubed for the volume. All right, last one. A solid consists of a hemisphere of radius 1 on top of a cone with the same radius and a height of 5. Find the volume of the solid and round to 2 decimal places. All right, let's draw it first. It's going to be a hemisphere on top of a cone. So basically, I think that's basically like an ice cream cone. Okay. So we're going to have a cone here. And then basically you draw a hemisphere on top. So let's see if I... All right, start with a cone and basically draw a hemisphere on top. All right, I'll do that in a different color. So imagine like an ice cream cone. The hemisphere on top. It says that the height is 5 meters. So if you go from the center of the circle of the cone and go to the vertex of the cone, that height is 5 meters. All right. And it says the hemisphere radius is 1 meter. And the cone has the same radius. So let's see, the hemisphere radius goes from the center to the circle itself. That's 1. All right. So we basically have a hemisphere on top. And a cone on the bottom. All right. So that's the volume. We're adding these two. This isn't subtracting this time. That's going to be the volume of a hemisphere plus the volume of a cone. All right. We said before the sphere volume is 4/3 pi r cubed. But for a hemisphere, it's going to be half of that. And the cone volume is basically 1/3 pi r squared h. All right. So we said the height is 5. We said the height is 5 and the radius is 1. All right. See if you can finish that, please. All right. Half of 4/3. We did this before. 4 divided by 2 cancels, and you're left with 2/3. That's going to be times pi times r cubed. What did we say the radius was? Just 1. So that's going to be 1 cubed. And we're going to add 1/3 times pi times r squared. Again, the radius is just 1. And the height is 5. So that's times 5. All right. You can do this in 2 steps or 1 step. I'm going to do it in 1 step. If you don't know how to do fractions, do 2 divided by 3, hit equals, and then times pi times 1 to the 3rd. All right. Hit equals. I get 2.09. And then do plus 1 divided by 3. Nope, scratch that. Keep this answer. Do plus pi times 1 squared times 5 divided by 3, and then hit equals. And I get 7.33. All right, the units were in meters, but that gets cubed. So that's going to be meters cubed. All right, make sure you practice this stuff like this on the calculator. If you want to do it in 2 steps, you can. If you want to do 2 steps, and then you can do 1 divided by 3, hit equals, and then times pi times 1 squared times 5. What you can do if you don't know how to do fractions on the calculators, when you do 2 divided by 3, use parentheses around that. Same with 1 divided by 3, use parentheses around that. And then you can multiply the other stuff. All right, so on number 21, you're going to subtract the hemisphere, okay? On 21, it's going to be the volume of a cylinder minus the hemisphere. Okay, you're just subtracting. And then on number 23, just like the example we just did, it's going to be the volume of the cone plus the hemisphere. And that's like the one we just did.